Hello and welcome to another video. In this video we're going to be working on time needed to buy tickets. And so in this problem you have a line of people and each person's trying to buy tickets. And they tell you how many tickets each person needs by the index. So here we have an example of tickets. So like person 0 needs 2 tickets, person 1 needs 3, person 2 needs 2. And whenever you buy a ticket, you go to the end of the line. And if you don't need any more tickets, then you just leave the line. And so given an integer k, you want to return how long it takes before that person buys all the tickets they need. So in this first example, let's walk through this one. We want to return how long it takes before this person too buys all the tickets they need. So they kind of show you what happens. So in the first pass, every single one of these people buys a ticket, right? And we can even do like a quick demo of this. So let's say we have an array. Let's actually use an indexed array. So we have 3 people and they all need to buy some tickets. So let's just say this is 232. So basically what would happen here is in the first second, this person buys a ticket and then they go to the end of the line like this. Then this person buys a ticket. And then this person buys a ticket. So this person will go to the end of the line and then this person will go to the end of the line. So that's like one pass, right? In the second pass, same exact thing. So this person buys a ticket. I'm not going to show them going to the end of the line because it'll basically just rotate back to this again. So it'll be like this. And then you're done right here, right? Because this person too now needs no more tickets. So this took 6 seconds. So that's what you return. So in the second example, in the first pass, everyone buys a ticket, and then all of these other people here don't need anything else. So they don't need any more, so they're just out of the line. So after the first pass, your array of people is just the one person who needs 4 tickets. So that person will just keep buying a ticket until they don't need any more. So you'll have 8 total. So let's walk through like this example, and let's figure out, like let's say we're looking for this person. Let's just pick some random person like this. We are asked like how long it takes before this person gets their tickets. So we could do this like pass thing, but the problem is, what if these numbers get really big? Like what if these numbers are like 10 to the 5th or something? Then you're going to have to do like 10 to the 5th passes of the array, which will be n squared. But we don't really need to do that. We can just figure out quickly how much each person will contribute into the time for this person to get a ticket. So let's split this up into people before k and people after k. So, and let's think of a couple examples. So for example, this person needs to buy 20 tickets. So how much time will this person contribute to the total time for this person to buy 6? Well, after 6 cycles of this whole thing, right, this person will need 14 tickets left, right? Like if we just go through this array 6 times, this person will need 14 tickets left, and then this person will be at 0. So the most each person can contribute before this person is k, right? So we can write this down. So people before k, if number is greater than k or equal to k, time equals k. So this person will contribute 6 seconds. Now what about this person here, right? So this person here. How much time can they contribute? Well, they're going to buy, after 3 cycles, they're going to be at 0, and then they're just going to be removed from the line. So this person can only contribute 3 seconds. So basically, as a generic equation here, we can just say like time for the people before is the minimum of time for the person, so, or tickets for the person, and k, right? So if this number is less than k, which is like this. So what I mean by k is like the number of tickets that the kth person needs. If this is less than that, then this will just contribute that number. If it's greater than or equal to it, it'll only contribute that number as well. So this person will contribute 6, or not 6, 3. Then this person will contribute 5. This person will contribute 1, 2, and 5. And that's because after that amount of cycles, like for this person, after 5 cycles, this person will be at 1, and this person's done. So the most time someone can contribute is how many tickets they have, right? It takes 1 second to buy a ticket. If they only need 5 tickets, they can only contribute 5. But if they need to buy 20, then after 6 cycles, this will be done. So we don't really care about like what this is left. Now let's take a look at the people after k, and this is basically the same thing with one small change. So in 6 cycles, what's going to happen here is, like, after the 6th cycle, this will go to 0, and this would still be the value that it was after 5 cycles, right? So this would still be 3. Because after 5 cycles, this would be 1, this would be 3, right? Because you would just go through 5 times, so subtract 5 from each. Then on the 6th cycle, you'd come here, this would turn to 0, and this would stay at 3 because you're done with this, so you don't really care that you have this. So for people after, it's the same thing, right, with a small change. So it's no longer number of tickets k, it's actually just k minus 1. Because the most any person can contribute is k minus 1. Because if we have an array of like 2 people, like this, and this person needs to buy 6 and this person needs to buy 6, and we care about this person. So if we just go cycle by cycle, this will, like, we can write that down, right? So this will go down to 5, then this will go down to 5, then this will go down to 4, then this will go down to 4, and so on and so on and so on. And then when both of these are 1, then this will go down to 0, and then we're done. So from 6, this took 6 seconds, but this only took 5. So that's why it's k minus 1 here. So for the people after, it's this formula here, right? Still the most time they can contribute is like let's say this number was like a 3 instead. So this started off as a 6, so if this was 3, then this person would still only contribute 3 seconds. But the most they can contribute is now k minus 1. And then finally, we have our last thing. So we take all the people before, all the people after, and then the actual k value itself. So the kth person will always contribute like all the tickets they need to buy. So the total will be time for all the people before plus, you know, tickets k plus time after. And that's basically it. So we can do these in O of 1 because we can recognize like how much time each person can contribute quickly instead of having to like loop and loop and loop and loop and loop and loop. And so this is like an optimization for easy problems that you're going to have to get used to, is like the brute force would just be a loop through the whole thing and then keep like simulating this, but you can recognize how much time each person can contribute quickly instead of looping. So that's what we're going to code. So we're going to say, so first we want like the actual, like how much person k will contribute. So we can say like k time or something, because we need that to figure out how, like, what's the most the other people can contribute. So this is going to be tickets k. Then we'll have our result, and we can even set it to tickets k for now because that will be part of the result. And then we can just add all the other people. So we're going to loop through all our tickets. So just normal loop, and then I is less than tickets length. So we're going to check, is this person before k or is he after k, or is they after k? So if I is less than k, then if we go back to our formula, so if it's less than k, then most time they can contribute is the minimum of the number of tickets they have in k. So that's what we're going to add. So we're going to say result plus equals the minimum of the tickets of that person and k. Right, because the most they can contribute is k, but if they have less tickets than k, then they're only going to contribute tickets they have. And then we can copy this and make our change for after k. And now this is just k minus 1. So the most they can contribute is k minus 1. This is the upper bound. And we already have the k time already included in our result. So this is the people before, the people after, and the actual person themselves. So we can just return now. So return. I have this. Okay. And we can submit, and hopefully, oh, looks like we got something wrong. Okay, so k equals 0, output is 2. Oh, yeah, so this shouldn't be k, this should be k time, right? Because the most they can contribute isn't the actual index, it's actually the time that the k person can contribute. So this is all, so actually these two should be k, these should be k time. So there we go. Okay. Okay. So once again, kind of like yesterday, we took a problem and instead of simulating the queue, we just figured out how many tickets each person contributes quickly and more efficiently. So this is going to be an O of n runtime, and the space will be O of 1 because we just have 2 variables. So yeah. So yeah, it's going to be all for this one, kind of similar to the last one. You know, figure out like what the brute force looks like and figure out how you can optimize the brute force. instead of looping, figure out like how you can do it quicker. And so definitely should be able to do problems like this to do harder ones. And yeah. And yeah, as always, if you have any questions, just ask in the comments. And if you did like this video and this is helpful, please like and subscribe. And I'll see you next one. Thanks for watching.